Alright, dear children, we do again continue with the solving numerical problems, based on first law thermodynamics. Okay, now we solve now two more numericals. Then with that numericals, your chapter thermodynamics get completed. Okay, now we solve now next problem, that is problem number 5. The problem number 5 says that an electric heater supplies heat. So electric heater supply what? Heat. Okay, to a system at a rate of 100 watt. 100 watt. So what is watt? 100 watt is the power of electric heater. What power? Power means the work done per unit time. Okay, that means the heat energy supplied by the electric heater is how much? 100 watt. Okay, full stop. Then after question say that the system performs work. Definitely with this heat supplied to the system performs works at a rate of 75 joule per second. So in 1 second, how much work is done by the system? That is 75 joule. The question says that at what rate is the internal energy increasing? At what rate the internal energy increasing? So we need to calculate the rate in which the internal energy increases. Okay. Now to do this problem, so basically we use first law of thermodynamics. So as for first law of thermodynamics, children, you know that the change in internal energy of the system is actually measured by the relation, that is delta U equals to Q minus W, where Q is the amount of heat supplied to the system, W is the work done by the system, and this delta U is the increase in internal energy of the system. Okay. Now, who is supplying heat to the system? Electric heater. And this electric heater supplies the heat to a system at a rate of 100 watt. That means 1 second, how much joule of heat energy that is supplied to the system? 100 joule. And due to this, that system do work at a rate of how much? 75 joule per second. So in 1 second, how much joule of work is done by the system? 75 joule. So definitely, under this question, we need to calculate the increase in what energy? Internal energy. So children, Q is the amount of heat supplied to the system. Okay, that is 100 watt. But this heat is the heat which is supplied at the system at the rate of 100 watt. Now 100 watt means also written as 100 joule per watt second. That means the how much amount of heat that is supplied by the system, okay, by the heater to the system, 100 joule of heat to the system in how many seconds? Just 1 second. Okay, that is 100 joule of heat. I don't know, is 100 joule of what? 100 joule of what? Heat, okay, energy supplied, okay, to the what? System. In how many seconds? 1 second. So just in 1 second, this much amount of heat is supplied to the system. And due to that, the work is done by the system, and that work done is also at a rate of how much? 75. It is given 75 joule per second. That means how much joule of work is done by the system? 75 joule of work in how many seconds? 1 second. This means 75 joule of work done, okay, by the what? System. 75 joule of work done by the system in how many seconds? 1 second. Now to calculate the internal energy of the system, increase in internal energy system, means at what rate the internal energy of system increases. So I use the formula of first law of thermodynamics, which I have already written. So the formula is delta U equals to what? Q minus what? W. So Q is how much? 100. W is how much? 75, which means it is 25. Okay, this is what? 25. And I write the unit joule per second. This is joule per second. That means by what rate the internal energy is increasing? 25 joule per second. This is 25. Okay. So this work, change in internal energy, which is what? Positive. This increase in internal energy or change in internal energy is positive, which means that the internal energy is increasing. Okay, because work done is positive, heat supply is also positive. So this internal energy is also, change in internal energy is also what? Positive. So I write down therefore the rate of increase, let me write down the rate of increase of what energy? Internal energy is how much? 25 watt. This W means what? Because 125 watt means 25 joule per second. That means in 1 second, what amount of inter-energy is increasing? 25 joule of inter-energy is increasing in 1 second, which means the rate of increase of inter-energy is simply 25 watt. So this is the solution of problem number what? 5. Now I'll be solving the last numeric problem, and with that the chapter get completed. And this is problem number what? 6. And children, problem number 6 says that a gas is taken from an original state A, original state is A, to an intermediate state C. Taken from original state A to intermediate C means it goes this way. So there is an arrow which is shown that A, first it goes from A to B, then B to C, then finally it comes back to from C to what? A. Okay. So gas is taken from original state A to an intermediate state C by the linear process, by number of process. Okay, as shown in figure. Its volume is then reduced to the original value from C to A. That means the volume of the gas reduced from C to A. Okay, from C to A by and what process? Isobaric process. And you know, in case of isobaric process, the pressure remains constant. And when there is isochoric process, what is remain constant? Volume remain constant. So these are the processes that you have learned in details under the application of thermodynamics. Okay. Now calculate the total work done by the gas from this process. In this process, from B to C, C to A. That means in this process, what is the total amount of work which is done by the gas? Now how to calculate the total work done by the gas? And you know, work done by the thermodynamic system is measured by what? As we have learned, as pressure into volume. But this process, if you look at this process, and this is a process which is calculated, which we can see under pressure volume versus volume graph. And under PB graph, when the process starts from A, original state, okay, goes to B, then to C, and return back to A, then this particular process is also known as what process? Cyclic process. That means the gas undergoes what process? Cyclic process. And what process, which path it follow? The clockwise path. Okay, so this process is called cyclic process. And to calculate work done by the gas under cyclic process is always calculated by the area of the shaded region, which is formed by the what? Gas. That means the area of the cycle, which is formed by the what? Gas. So this is the cycle which is formed. But what is the area? What type of cycle is formed? Triangular cycle. So we know the area of triangle. So we use the formula of area of triangle, and that area of triangle is actually the work done by the what? Gas. Okay. But children, look at this graph carefully. When the process starts from A to B, the volume remaining constant. Volume remain constant. So the pressure increases from 300 to 600. Okay, Newton per meter square. So when process goes from A to B, which process takes place? Isochoric process takes place, because volume remain constant. Okay, because when it goes from A to B, the volume remain constant, so that no work is done by the gas. No work is done by the gas when we move from A to what? B. That means work done can be calculated only when we move from B to C, C to A. Okay, but when we move from B to C, you can see there is a pressure decreases from 600 to 300 because volume increases. Pressure decreases when volume increases. And lastly, when you move from C to A, in this case the volume decreases from 5 meter cube to 2 meter cube, but pressure remaining same. That's why under the process called C to A, the pressure remaining constant, and this process called isobaric process. So A to B, isochoric process, C to A, isobaric process. But for one complete process, which is also called cyclic process, okay, the work done by the gas can be calculated by the area of the cycle formed under the cyclic process. Okay, so I write down simply that the gas undergoes what? The gas has undergone, let me write undergone, okay, what process? Cyclic process. Undergone a cyclic process. That means the cyclic process means from A to B, B to C, and C to what? A. Okay, that's why I calculate directly work done by the what? Gas is equal to the what? To the area of cycle. And that work done is given by W, and that W equals to what? Area of the cycle, which is formed as ABC, which means this is a triangle. And you know what is the formula of area triangle? Half into base into height. So in this right angle triangle, this is your base, this is your what? Height. And the formula is area of triangle equals to half into base means AC, and your height is what? AB. Height is what? AB, which means half into AC. Now AC means 5 minus 2. So I write down 5 minus 2 meter cube into AB. AC means 5 minus 2, and AB means 600 minus 300, because this distance reference is called 600 minus 300, that is AB. So I write down 600 minus 300. And this is 1 by 2 into 3. 600 minus 300 means 300. Okay, now we can divide this 2 ones are 2, 2 150s are 300. So 3 into 150 means how much? 450. And the unit is what? Joule. And the unit is what? Joule. So what is the work done by the gas under this process called cyclic process? 450 joule. Okay, so keep in mind, children, that when you see this type of process like a cyclic process, the work done by the gas or by the system is always equals to the area of the cycle. Now in this case we see the cycle is like a triangle. It can be like a quadrilateral, like rectangle, it can be any shape. But the work done by the system or by gas is always equals to the area of the what? Cycle. So this is the problem based on cyclic process. So the answer is 450 joule. So children, with this numerical problem, your chapter, one of the important chapter, thermodynamics, is completed. Now from next we start with the new chapter, okay, that is isothermal process and adiabatic process. Thank you so much.